Suspended in the vastness of space, our planet glimmers as a radiant blue sphere, its surface dominated by the endless embrace of the ocean. This immense aquatic realm is not merely a feature of Earth, it is its defining characteristic, a living, breathing entity that shapes the very fabric of our world. The ocean's reach is staggering, stretching across more than 70% of the globe. From pole to pole, it forms a seamless, undulating expanse, its surface reflecting the ever-changing moods of the sky above. Beneath its shimmering surface lies nearly all of Earth's water, an astonishing 97%, locked in a dynamic cycle of evaporation, condensation, and precipitation that sustains life on every continent. Even the mightiest rivers and the largest lakes are but fleeting threads compared to the ocean's vast tapestry. Their combined volume is dwarfed thousands of times over by the deep, ancient waters that encircle the continents. To gaze upon the horizon is to witness infinity, a boundaryless world where the sea meets the sky, hinting at the ocean's true immensity and the mysteries it conceals. Beneath the waves, the ocean floor is a landscape of extremes. Towering underwater mountain ranges such as the Mid-Atlantic Ridge stretch for tens of thousands of kilometers, while yawning trenches like the Mariana Trench plunge deeper than Mount Everest is tall. Over billions of years, these submerged realms have been sculpted by tectonic forces, volcanic eruptions, and the slow accumulation of sediments, creating habitats as varied and complex as any found on land. The ocean is a cradle of life, its waters teeming with an astonishing diversity of organisms. Coral reefs, often called the rainforests of the sea, burst with color and activity, supporting intricate webs of life in their labyrinthine structures. Scientists have catalogued nearly 250,000 marine species, from the smallest bioluminescent plankton to the most formidable apex predators. Yet experts estimate that millions more remain undiscovered, hidden in the ocean's unexplored depths. Each year, more than 2,000 new species are described, revealing creatures with extraordinary adaptations, some glowing with their own light, others thriving in scalding hydrothermal vents or under crushing pressures miles below the surface. The ocean's inhabitants span a breathtaking range of sizes and forms. Microscopic plankton, invisible to the naked eye, drift in vast clouds, forming the foundation of the marine food web. At the other extreme, the blue whale, Earth's largest animal, glides through the open sea, its heart alone weighing as much as a small car. Life in the ocean is a relentless contest for survival. Predators and prey are locked in an endless dance, each adapting in remarkable ways, camouflage, speed, venom, and armor, to outwit and outlast their rivals. Every day, epic battles unfold in the shadows of kelp forests and the open blue, from lightning-fast dolphin hunts to the silent, patient stalk of the deep-sea squid. These are stories of cunning, cooperation, and raw power, written in the language of survival. The ocean is more than a habitat. It is the planet's life support system. Its swirling currents distribute nutrients and energy, sustaining vibrant ecosystems from the sunlit shallows to the pitch-black abyss. Through the silent work of phytoplankton and seaweeds, the ocean generates over half of the oxygen we breathe, outpacing even the world's greatest forests. These microscopic plants harness sunlight, transforming carbon dioxide into life-giving air. The ocean's vast currents act as planetary arteries, transporting heat from the equator to the poles and regulating Earth's climate. These invisible rivers of water, like the Gulf Stream, shape weather patterns and influence the fate of entire continents. This perpetual motion is Earth's natural thermostat, moderating temperatures and making the planet habitable for countless forms of life. The health of the ocean is inseparable from the health of the planet. When coral reefs bleach or waters warm, the effects ripple outward, threatening the delicate balance that sustains life everywhere. The ocean is a force of nature, capable of both serene beauty and overwhelming power. Its waves sculpt coastlines, its storms can reshape entire landscapes, and its tides pulse with the rhythm of the moon. To journey beneath the surface is to enter a world of perpetual twilight, where sunlight fades and the unknown beckons. Here, every dive is an exploration, every discovery a revelation. In the ocean's deepest, darkest reaches, giants roam, creatures adapted to crushing pressure, eternal night, and the hunt for elusive prey. These are the true titans of the deep, shrouded in mystery and legend. Among them, the sperm whale stands unrivaled, a master of the abyss, capable of diving over 1,000 meters in search of its quarry, guided by the largest brain on the planet. In the silent darkness, it faces off against colossal squid in battles that have inspired myth and science alike. These encounters are a testament to the raw drama and complexity of life far beneath the waves. Join us as we delve into the extraordinary life of the sperm whale, a true titan of the deep and a living symbol of the ocean's enduring power, mystery, and wonder. Journey back in time, nearly 50 million years ago, to a world where the ancestors of whales roamed the land. These early mammals were nothing like the ocean giants we know today. Instead, they were small, hoofed creatures, quietly moving through dense forests and grassy plains, their bodies perfectly suited for life on solid ground. Imagine a tiny, deer-like animal, nimble and alert, foraging among the undergrowth. These were the distant relatives of modern whales, their evolutionary journey just beginning. Among these ancient mammals was Pachycetus, a remarkable transitional species. Its fossils reveal a creature caught between two worlds. Its limbs still adapted for walking, yet its body slowly transforming for a life in water. Over countless generations, these animals ventured into rivers and lakes, their bodies gradually evolving. Limbs became flippers, nostrils shifted atop their heads, and tails grew powerful for swimming. Eventually, the mighty Basilosaurus emerged, a massive serpent-like whale, fully aquatic and dominating the ancient seas. It was a true marvel of evolution, paving the way for the giants that would follow. Today, the sperm whale stands as the last living member of its ancient lineage, the genus Physeter. It carries within its DNA the story of survival, adaptation, and transformation across eons. The sperm whale is not just a creature of the deep, it is a living legend, inspiring myths and tales across cultures. Its sheer size and mysterious nature have fascinated humans for centuries. Instantly recognizable, the sperm whale's colossal block-shaped head is a marvel of natural engineering. This head houses the largest brain of any animal on Earth, weighing up to 9 kilograms, and a unique organ called the spermaceti organ, which plays a crucial role in buoyancy control and echolocation. Unlike baleen whales that filter feed on tiny plankton, the sperm whale is a formidable predator. Its mouth is lined with rows of conical teeth, perfectly designed for grasping slippery prey in the darkness below. As the largest toothed predator on the planet, the sperm whale hunts giant squid and deep-sea fish, sometimes diving over 2,000 meters, deeper than any other mammal, to pursue its quarry. In the inky blackness of the ocean's midnight zone, the sperm whale reigns supreme. Here, under crushing pressure and total darkness, it navigates with astonishing precision, using powerful clicks and sonar to map its surroundings and locate prey. Its body is a masterpiece of strength and endurance, with thick layers of blubber for insulation and powerful muscles for long, deep dives that can last over an hour. Sperm whales are true citizens of the world's oceans, thriving from the frigid polar seas to the sunlit tropics. Their adaptability allows them to survive in a vast range of temperatures and conditions. These giants are also among the greatest travelers on Earth, migrating thousands of kilometers across open oceans in search of food and mates, often forming tight-knit social groups known as pods. While they must surface to breathe, releasing a distinctive angled spout, sperm whales spend most of their lives hidden in the ocean's twilight and midnight zones, far from the reach of sunlight. In these shadowy depths, sperm whales are perfectly adapted to withstand immense pressure and near-freezing temperatures. their physiology fine-tuned for survival in one of Earth's most extreme environments. The evolutionary journey of the sperm whale is a testament to nature's ingenuity. From land-dwelling ancestors to oceanic titans, each adaptation tells a story of resilience and change. To look into the eye of a sperm whale is to glimpse the wisdom of the deep. These animals possess complex social structures, communicate with intricate patterns of clicks, and display remarkable intelligence. Sperm whales thrive in some of the harshest environments on the planet, even near volcanic vents, where life is both dangerous and abundant, showcasing their extraordinary adaptability. Their echolocation is among the most powerful in the animal kingdom, producing clicks that can be heard for miles and used to stun prey or communicate across vast distances. As apex predators, sperm whales shape the deep-sea ecosystem, influencing populations of squid and fish and maintaining the delicate balance of life in the abyss. Studying the sperm whale unlocks secrets of the deep ocean, revealing a hidden world that covers most of our planet yet remains largely unexplored. So, as we dive deeper into the life of this magnificent ocean giant, prepare to discover a creature whose story is as vast and mysterious as the sea itself. In the vast, mysterious expanse of the ocean, one creature stands out as a true titan, the sperm whale. Its sheer presence commands respect, a living relic of the deep whose story is written in the language of size, power, and adaptation. Sperm whales are the largest of all toothed predators, their bodies streamlined for endurance and strength. They glide effortlessly through the water, their massive forms dwarfing nearly everything around them. Adult males can reach an astonishing 16 meters in length, their bodies stretching longer than a city bus, while their weight can tip the scales at 45 tons, an immense mass supported by powerful muscles and a robust skeleton. To put this into perspective, a single adult male sperm whale outweighs a herd of elephants, its bulk a testament to the evolutionary arms race of the deep sea. Females, though smaller, are still giants in their own right, reaching up to 11 meters and weighing around 15 tons. Calves, born after a gestation of over a year, are already several meters long at birth, ready to face the challenges of the ocean. The dramatic size difference between males and females is one of the most pronounced among mammals, shaping their social structures and behaviors. Males often roam the open ocean alone, while females and young form tight-knit pods, working together to protect and nurture their young. Among the giants of the sea, sperm whales are surpassed in size only by the blue whale and the fin whale, but their unique adaptations set them apart from all others. Only these two colossal baleen whales outsize the sperm whale, but none can match its prowess as a deep-diving predator. The blue whale, the largest animal to ever exist, can reach over 30 meters and weigh up to 200 tons, a true leviathan of the sea. The fin whale, nearly as impressive, is just a shade smaller, yet still a marvel of marine evolution. But among all toothed whales, the sperm whale reigns supreme. Its jaws are lined with conical teeth, perfectly adapted for grasping slippery prey in the inky blackness of the deep. Sperm whales are legendary hunters, capable of diving over 1,000 meters in search of their favorite meal, giant squid. In these pitch-black depths, they rely on echolocation, sending out powerful clicks that echo through the water, painting a sonic map of their surroundings. The sperm whale's enormous head, making up a third of its body length, houses not only the largest brain on Earth, but also the spermaceti organ, a mysterious structure that aids in buoyancy and sound production. The average sperm whale brain weighs nearly 8 kilograms, with some individuals boasting brains over 9 kilograms, an organ of staggering complexity and size. This brain is not just large, it is intricately folded with deep grooves and ridges that increase its surface area, allowing for advanced processing and coordination. These elaborate folds are thought to be linked to the whale's sophisticated social behaviors, communication, and navigation abilities. The brain's vast surface area is a testament to the sperm whale's need for complex thought, memory, and sensory integration in a world where light never reaches. As the sperm whale descends into the abyss, its body undergoes remarkable changes. Its rib cage collapses to withstand the pressure, and its heart rate slows, conserving oxygen for the long hunt. In these silent depths, the sperm whale moves with purpose and intelligence, its every motion calculated for survival, in a world few creatures dare to enter. Its echolocation clicks are the loudest sounds produced by any animal, capable of stunning prey and communicating across vast distances in the ocean. Sperm whales use these sounds not only to hunt, but to maintain complex social bonds, sharing information and coordinating movements within their pods. Navigating the labyrinthine seascape, sperm whales demonstrate remarkable spatial memory and problem-solving skills, adapting to ever-changing conditions in their three-dimensional world. Their brains are specialized for processing vast amounts of acoustic information, allowing them to hunt, communicate, and orient themselves in the pitch-black depths where vision is useless. In every way, the sperm whale is a marvel of evolution, a true giant of the ocean, perfectly engineered for life in the planet's most extreme and mysterious realm. In the vast expanse of the world's oceans, one creature reigns supreme as the ultimate deep-sea explorer, the sperm whale. These colossal mammals are not only the largest of the toothed whales, but they are also the most accomplished divers among all air-breathing animals. Sperm whales spend much of their lives in the twilight and midnight zones of the ocean, descending into the inky blackness in pursuit of their favorite prey. Giant squid and other deep-sea creatures that few eyes have ever seen. A typical foraging dive takes a sperm whale to depths ranging from 300 to 1,200 meters, where the pressure is dozens of times greater than at the surface, and the temperature plummets to near freezing. At these depths, sunlight is nothing but a memory. The world becomes a realm of perpetual darkness, where only the faintest glimmers of bioluminescent life flicker in the void. Yet the sperm whale's capabilities do not end there. These giants are known to push the boundaries of what is possible for a mammal. Scientists, using sophisticated tracking devices, have recorded sperm whales plunging to an astonishing 2,250 meters, deeper than any other whale and deeper than most submarines can safely travel. To put this feat into perspective, imagine descending the height of 22 football fields, straight down into a world where the pressure would crush a human-built submarine without special reinforcement. This is the daily reality for the sperm whale, a journey into the abyss that few living creatures could ever survive. These epic dives are not brief excursions. Sperm whales can remain submerged for up to 90 minutes at a time, navigating the pitch-black depths with astonishing precision. Holding their breath for an hour and a half, they search for prey in a world where every movement must be calculated to conserve precious oxygen. This remarkable breath hold is made possible by a suite of extraordinary physiological adaptations, honed by millions of years of evolution. The sperm whale's body is a marvel of natural engineering, streamlined and muscular, shaped like a living torpedo to minimize drag and maximize efficiency as it glides through the water. Every aspect of its anatomy is designed for deep diving, from its powerful flukes to its robust hydrodynamic form. One of the most critical adaptations is the flexibility of its rib cage. Unlike most mammals, the sperm whale's ribs can fold inward, allowing the chest cavity to collapse under pressure and preventing the lungs from being crushed by the immense weight of the water above. Oxygen management is another key to their success. Sperm whales have evolved to store vast reserves of oxygen, not just in their lungs, but throughout their bodies. Their muscles are packed with myoglobin, a specialized protein that binds oxygen and allows it to be stored directly within the muscle fibers, far more efficiently than in most land mammals. Their blood, too, is uniquely adapted. Sperm whales possess a much higher volume of blood relative to their body size, and this blood is densely packed with red blood cells, each one a tiny vessel for transporting oxygen to vital organs. During a dive, the whale's heart rate slows dramatically, sometimes to fewer than 10 beats per minute, reducing oxygen consumption and prioritizing delivery to the brain and heart. Blood flow is carefully regulated, with non-essential organs temporarily deprived so that the most critical systems remain supplied during the long, oxygen-starved descent. Deep within the whale's body lies another secret weapon, the retia mirabilia, a complex network of blood vessels that acts as a biological pressure regulator, buffering the whale against the rapid changes in pressure and helping to manage the distribution of oxygen and nitrogen. This intricate system prevents dangerous gas bubbles from forming in the blood, a risk that would threaten any other mammal attempting such extreme dives. All these adaptations combine to make the sperm whale a living submarine perfectly suited for life in the most extreme environment on Earth. In the crushing darkness where the pressure would destroy most life, the sperm whale moves with confidence and grace, a true master of the abyss. The sperm whale does not merely visit the deep ocean, it has conquered it, transforming the cold, dark, and mysterious depths into its hunting ground, its sanctuary, and its home. Deep beneath the ocean's surface, where sunlight fades and darkness reigns, the world is ruled not by sight, but by sound. The sperm whale's massive head is a marvel of evolution, concealing one of the most extraordinary adaptations in the animal kingdom. Inside, a vast chamber is filled with a unique, oily wax called spermaceti, a substance that has puzzled scientists for centuries. This chamber can hold nearly 2,000 liters of this remarkable liquid, making it one of the largest biological reservoirs in the animal world. For decades, the true function of the spermaceti organ remained a mystery, but modern research has revealed its dual purpose, both as a tool for buoyancy and as a sophisticated acoustic device. First, let's explore its role in buoyancy control, a critical adaptation for a creature that must dive to depths exceeding 1,000 meters in search of prey. As the whale prepares to descend, it draws cold seawater through its nasal passages, cooling the spermaceti oil within its head. This cooling process causes the oil to solidify, increasing its density and making the whale's head heavier. The added weight allows the whale to sink effortlessly into the crushing depths, conserving precious energy for the hunt ahead. When it's time to return to the surface, the whale increases blood flow to the spermaceti organ, warming the oil and causing it to melt. As the oil becomes less dense, the whale's buoyancy increases, helping it rise gracefully through the water column with minimal effort. This ingenious system allows the sperm whale to make repeated, energy-efficient dives into the ocean's twilight zone, where few other predators can follow. But the true power of the spermaceti organ lies in its role as an acoustic powerhouse. In the deep sea, where light cannot penetrate, sound becomes the primary sense for navigation, communication, and hunting. The spermaceti organ acts as a biological lens, focusing and amplifying sound waves generated within the whale's head. Sperm whales produce powerful clicks not with vocal cords but with specialized structures in their nasal passages known as phonic lips. These clicks are then reflected and concentrated by the spermaceti organ and the dense bones at the front of the skull, creating a focused beam of sound. The result is a sonic pulse so intense it is considered the loudest biological sound on Earth, reaching up to 236 decibels. These sound waves travel vast distances through the ocean, bouncing off objects and revealing the hidden world in the darkness. At close range, the force of these clicks is so powerful it can physically stun or disorient prey, such as giant squid, making them easy targets for the whale. This biological sonar, known as echolocation, allows the sperm whale to see with sound, detecting the faintest echoes from distant or hidden creatures. In the pitch-black depths, where vision is useless, the whale's acoustic abilities give it a decisive advantage, transforming the ocean into a battlefield of echoes and vibrations. With each click, the whale maps its environment, locates prey, and communicates with others across kilometers of open water. In this silent, shadowy world, sound is not just a sense, It is survival, and the sperm whale is its undisputed master. In the deep ocean, sunlight is a distant memory. Here, at depths beyond 1,000 meters, darkness reigns supreme. It is a world of absolute blackness, where vision is rendered useless and only the most specialized creatures survive. Among these, the sperm whale stands as a true master of the abyss, relying on extraordinary adaptations to hunt in this eternal night. Its most remarkable weapon is echolocation, a biological sonar system that transforms sound into sight. The whale produces a series of powerful, focused clicks, each one reverberating through the water like a pulse of energy. These sound waves travel vast distances, bouncing off anything in their path, be it a drifting fish, a lurking squid, or the jagged walls of a submarine canyon. The returning echoes are captured by the whale's lower jaw, which is packed with specialized fat that channels the vibrations directly to its inner ear. Deep within its massive skull, a highly developed brain deciphers these echoes, constructing a vivid, three-dimensional map of the world, one built entirely from sound. This acoustic vision allows the sperm whale to see in total darkness, detecting the faintest movement or the subtlest shape in the water. With each click, the whale can judge the size, distance, and even the texture of objects, distinguishing between the soft body of a squid and the hard shell of a crustacean. The hunt begins with slow, deliberate clicks, each one a probing question sent into the void, searching for the telltale echo of prey. This scanning phase is like sweeping a searchlight across a pitch-black landscape, methodically mapping every contour and movement. As the whale glides silently through the water, it listens intently, piecing together a mental image of the ever-shifting seascape. When a distant echo hints at the presence of a potential meal, the whale's focus sharpens and its strategy shifts. It alters its clicking pattern, increasing the frequency and intensity as it zeroes in on its target, often a giant squid lurking in the gloom. The clicks accelerate into a rapid-fire buzz, a high-speed barrage of sound that gives the whale a real-time, high-definition image of its prey's every move. In this buzz phase, the whale can unleash up to 50 clicks per second, tracking the frantic escape maneuvers of its quarry with astonishing precision. It's as if the whale is zooming in with a camera lens, locking onto its target with unwavering focus. Every twitch, every pulse of a fleeing squid is mapped in exquisite detail, allowing the whale to anticipate and counter its prey's evasive tactics. This level of precision is vital for capturing agile, fast-moving animals in a world where a single mistake means going hungry. The sperm whale's hunting strategy is a symphony of adaptation, combining raw power, acute sensitivity, and relentless patience. In a fraction of a second, it sends out a click, receives the echo, and updates its mental map, navigating a labyrinth of canyons and currents with ease. This ability allows the whale to hunt in the most challenging environments, twisting through underwater ravines, weaving between rocky outcrops, and pursuing prey into the narrowest crevices. In the pitch-black expanse of the deep sea, the sperm whale's clicks become its eyes, transforming the void into a world of opportunity. It is the ultimate sonic predator, an apex hunter perfectly engineered for survival in the most extreme darkness on Earth, wielding one of nature's most advanced sensory systems with unmatched skill. The sperm whale is a legend of the deep, but the ocean is home to a remarkable cast of other champions, each with their own extraordinary adaptations for survival in the abyss. Among marine mammals, a select few have evolved to push the boundaries of what's possible beneath the waves, venturing into crushing depths and enduring conditions that would defeat almost any other creature. The Cuvier's beaked whale, for example, is a master of the unknown. This elusive whale is rarely seen, but it holds the world record for the deepest and longest mammalian dive ever recorded. In 2014, scientists tracked a Cuvier's beaked whale as it plunged to an astonishing 2,992 meters, almost 3 kilometers straight down, where the pressure is nearly 300 times greater than at the surface. Even more impressive, another individual stayed submerged for 222 minutes, nearly 4 hours, on a single breath, a feat that demands extraordinary physiological control. The southern elephant seal is another deep-sea marvel. Unlike whales, this massive pinniped is a true seal, yet it rivals the giants in its ability to dive. With a face that hints at its terrestrial ancestry, the southern elephant seal is built for endurance and power. It is the deepest diving of all seals, capable of reaching the ocean's twilight zone with ease. Males have been recorded diving to 2,288 meters, deeper than any known sperm whale, using their immense size and specialized blood chemistry to survive the cold, dark depths. While their dives are typically shorter, lasting 20 to 30 minutes, they are relentless, surfacing only briefly before plunging again. Southern elephant seals can perform hundreds of these deep dives every day, tirelessly hunting for fish and squid in the inky blackness. Their enormous spleens act as oxygen reservoirs, releasing rich red blood during dives to fuel their marathon hunts. Sperm whales are the loudest animals in the ocean, using powerful, low-frequency clicks for echolocation that can travel for miles through the water. But the ocean's acoustic landscape is diverse. Bottlenose dolphins, for instance, have evolved a high-frequency echolocation system, allowing them to detect tiny fish and navigate intricate environments. While sperm whale clicks are deep and thunderous, perfect for scanning the vast open ocean, dolphin clicks are rapid and high-pitched, ideal for close-range precision. This gives dolphins a detailed acoustic image, enabling them to find prey hidden in sand or among rocks, and to weave effortlessly through coral reefs and kelp forests. Dolphins are also renowned for their intelligence and social complexity, using signature whistles to identify and communicate with one another, forming tight-knit pods that cooperate in hunting and defense. Each of these animals is a specialist, perfectly adapted to its own ecological niche in the vast ocean battlefield. The Cuvier's beaked whale is the ultimate depth specialist, with a streamlined body and collapsible lungs that allow it to withstand immense pressure. The southern elephant seal is the master of endurance, with a metabolism tuned for repeated, energy-efficient dives, and a physiology that resists the cold and hypoxia of the deep. The dolphin is the agile navigator, using acute senses and social intelligence to thrive in dynamic coastal environments, and the sperm whale is the powerhouse, a sonic giant that dominates the open ocean's twilight zone with its strength and sound. When we compare these champions, we see a tapestry of evolutionary solutions, each animal equipped with its own set of superpowers, from pressure-resistant bodies and oxygen-storing organs to advanced sonar and social strategies. The deep ocean is not ruled by a single champion, but by a diverse league of extraordinary survivors, each perfectly honed for their own domain. Deep beneath the ocean's surface, the family life of sperm whales unfolds in a world of remarkable complexity and subtlety. Female sperm whales and their young form the heart of these societies, weaving together generations in a tapestry of kinship and cooperation. Within these matrilineal pods, mothers, daughters, grandmothers and aunts live in close association, their bonds forged over decades. Each pod is a living lineage, with knowledge and traditions passed down from elder whales to the youngest calves. Males, on the other hand, follow a different path. As they mature, young males gradually leave the security of their family pod, first joining loose bachelor groups, then eventually leading solitary lives, traversing immense distances across the world's oceans. The arrival of a new calf is a moment of quiet celebration. After a 16-month gestation, the mother seeks out warm, sheltered tropical waters to give birth. The newborn, already 4 meters long and weighing over a ton, emerges into a world where every member of the pod plays a role in its survival. In its earliest months, the calf is fragile and dependent, shadowing its mother's side. Yet it is never alone. The pod surrounds the calf, offering protection, guidance, and even shared babysitting duties, a phenomenon known as alloparenting. Older females, often grandmothers or aunts, take turns watching over the young, allowing mothers to dive for food. This communal care ensures that calves are rarely left unguarded, and it strengthens the social fabric of the pod. When danger threatens, such as the approach of orcas, the pod's response is swift and coordinated. Adult females form a living barricade, arranging themselves in a defensive rosette with their powerful tails facing outward, calves sheltered in the center. This formation is more than a physical defense. It is a testament to the trust and cooperation that define sperm whale society. Each whale knows her place, responding to subtle cues and clicks that coordinate their movements with astonishing precision. As the calf grows, it learns by watching and imitating the adults. Nursing from its mother, it also observes the pod's daily routines: how to dive, how to navigate, and how to communicate in the language of clicks and coders. Sperm whales possess a sophisticated system of communication. They exchange coders, distinctive patterns of clicks unique to each pod, almost like a family dialect. These coders are not only a means of identification, but also a way to reinforce social bonds and coordinate group activities. Unlike the powerful echolocation clicks used for hunting in the abyss, social coders are softer, more rhythmic, and carry information about identity, intent, and even emotion. Each pod's repertoire is learned by the young as they grow, a cultural inheritance passed from one generation to the next. Through these daily interactions, nurturing, teaching, defending, and communicating, the pod becomes more than a group of individuals. It is a family bound by blood, memory, and the shared rhythms of life in the deep. In the vast blue wilderness, these bonds are the key to survival, and the story of every whale is written in the company of kin. Deep beneath the rolling waves, the sperm whale reigns as a silent sentinel, an ancient guardian whose presence shapes the very fabric of the ocean. These giants traverse vast underwater realms, their lives intricately woven into the health and balance of marine ecosystems. Every movement, every dive, and every breath echoes through the ocean's delicate web of life. Sperm whales are among the planet's deepest divers, plunging thousands of meters in search of prey. As they ascend, they transport nutrients from the abyss to sunlit waters, fueling a cycle that sustains countless species. Their feeding and waste release create a natural upwelling, delivering iron and nitrogen to the surface. This vital process, known as the whale pump, is a cornerstone of ocean productivity. The nutrients they provide spark immense blooms of phytoplankton, microscopic plants that form the foundation of the marine food chain and drive the ocean's ability to support life. Phytoplankton are not only the ocean's primary producers, but also the lungs of our planet, generating over half of Earth's oxygen and absorbing vast amounts of carbon dioxide. This invisible forest beneath the waves is essential for climate regulation and the survival of all marine creatures, from the tiniest zooplankton to the mightiest whales. By nurturing these microscopic plants, sperm whales indirectly support the entire oceanic food web, ensuring the resilience and diversity of marine life. Even in death, their legacy endures. When a whale's body descends to the seafloor, it becomes a whale fall, a rare and precious event that transforms the barren deep into a thriving oasis. Entire communities of deep-sea organisms flourish on these nutrient-rich remains, sustaining life in the darkness for decades and fueling the evolution of unique species. Around the world, innovative conservation efforts are underway to protect these ocean giants and the ecosystems they support. Marine protected areas spanning thousands of square kilometers offer safe havens where whales can feed, breed, and migrate undisturbed. Advanced acoustic monitoring and satellite tracking technologies are revealing the secret lives of sperm whales, guiding the creation of sanctuaries and informing global policy to reduce threats like ship strikes and entanglement. International collaborations are working to reduce ocean noise, regulate shipping lanes, and promote sustainable fishing practices, all to ensure the survival of these guardians and the countless species that depend on them. The health of sperm whales is a direct reflection of the ocean's vitality. Their well-being signals a thriving, balanced ecosystem where life flourishes at every level. Protecting these magnificent animals means safeguarding the intricate tapestry of oceanic life, from the smallest plankton to the largest predators. The sperm whale's superlatives are legendary: the largest brain on Earth, the deepest dives, and the most powerful vocalizations ever recorded in the animal kingdom. Their evolutionary journey from land-dwelling ancestors to deep-sea titans is a testament to nature's ingenuity and the relentless drive to adapt and survive. Masters of sound, sperm whales use sophisticated echolocation to navigate the abyss, communicate across vast distances, and hunt elusive prey in total darkness. Their epic battles with giant squid and their ability to thrive in the planet's most extreme environments reveal the extraordinary drama of life in the deep. As guardians of the deep, sperm whales inspire awe and respect, reminding us of the ocean's enduring mystery and the urgent need to protect its wonders for generations to come. Beneath the twilight zone, where sunlight fades into darkness, an intricate tapestry of life unfolds, a hidden web that sustains the deep ocean's extraordinary diversity. Here, every creature, from the smallest drifting plankton to the colossal sperm whale, plays a vital role in a complex system of interdependence. Microscopic phytoplankton, driven by the nutrients cycling upward from the abyss, form the base of this web. These tiny plants are consumed by zooplankton, which in turn feed a remarkable array of midwater fish, squid, and crustaceans. Lanternfish, numbering in the billions, migrate nightly from the depths to feast on this bounty, their shimmering bodies forming the largest migration on Earth. Predators stalk these midwater realms with specialized adaptations. The deep-sea squid, with its bioluminescent lure, hunts in the inky blackness, while gulper eels and anglerfish lie in wait, their gaping jaws ready to snap up unsuspecting prey. Each feeding event ripples through the ecosystem, transferring energy up the food chain and supporting an astonishing diversity of life. At the pinnacle, apex predators like the sperm whale orchestrate the flow of nutrients and energy. Their hunts for giant squid are legendary, shaping the behavior and evolution of both hunter and prey. But the cycle does not end with the living. When any organism dies, its remains drift downward, becoming food for scavengers and decomposers. This continuous rain of organic matter, known as marine snow, nourishes the deepest layers of the ocean, sustaining creatures that never see the sun. Even far below, in the pitch-black depths, life thrives around whale falls and hydrothermal vents where unique species flourish in isolation. Bacteria, worms, and crustaceans break down complex molecules, recycling nutrients back into the ecosystem. This relentless exchange ensures that nothing is wasted, and every life, no matter how small, plays a part in the ocean's grand design. The deep sea's food web is a marvel of resilience and adaptation, a testament to the interconnectedness of all marine life. Through this hidden web, the ocean remains a realm of endless discovery, its mysteries waiting to be unraveled in the darkness below. In the perpetual night of the deep ocean, where sunlight cannot reach, the darkness is pierced by nature's own lanterns, bioluminescent life forms. Here, light is not a gift from the sun, but a creation of the creatures themselves. Through extraordinary chemical reactions, organisms transform the blackness into a living constellation, each glow a signal, a lure, or a shield. Jellyfish drift like ghostly orbs, their bodies pulsing with electric blue and emerald green. Some, such as the siphonophore, stretch dozens of meters, their delicate filaments adorned with flickering lights that attract prey and confuse predators. The comb jelly, or catenaphore, ripples with rainbow-colored waves, its cilia scattering light in mesmerizing patterns. Farther below, the anglerfish reigns with its signature glowing lure, a luminous beacon that dangles before its jaws, enticing unsuspecting victims into a deadly trap. Other hunters, like the dragonfish, possess rows of photophores that can flash in precise patterns, communicating in the darkness or camouflaging their silhouette from creatures below. Even the tiniest inhabitants join in this silent symphony. Swarms of ostracods and copepods emit bursts of light, dazzling attackers and vanishing in the confusion. Some squid species release clouds of bioluminescent ink, a glowing smokescreen that conceals their escape. Bioluminescence is not simply a spectacle, it is a tool for survival. Some fish use counter-illumination, matching the faint light from above to render themselves invisible to predators lurking below. Others synchronize their flashes for courtship, sending coded signals across the gloom. This radiant tapestry reveals a world where light is life and every spark serves a purpose. In the abyss, the language of light is as intricate as any spoken on land, a testament to the ingenuity of evolution, and a reminder that even in the deepest darkness, life finds a way to shine. Beneath the surface of the world's oceans, immense rivers of water surge silently, shaping the destiny of all marine life. These are the ocean currents, vast, ceaseless flows that journey thousands of miles, weaving a complex web of movement across the globe. Unlike the visible drama of the waves above, currents are the invisible highways of the deep, transporting nutrients, heat, and life itself. In the open ocean, powerful currents like the Gulf Stream and the Kuroshio Current sweep warm water across continents, transforming entire ecosystems in their path. They carry microscopic plankton, the foundation of the marine food chain, distributing these vital organisms to every corner of the sea. Where cold, nutrient-rich currents upwell from the abyss, they ignite explosions of life, fueling blooms of plankton that feed great shoals of fish, whales, and seabirds. For many marine species, these currents are both guide and guardian. Sea turtles, for example, hatch on distant shores and drift with the currents for years, embarking on epic migrations that span oceans. Tiny larvae of coral, fish, and crustaceans ride these flows to new habitats, ensuring the survival and genetic diversity of their kind. Even the mighty blue whale times its journey to follow the invisible trails of food delivered by the moving water. Yet, the influence of currents reaches far deeper. In the twilight and midnight zones, slow-moving thermohaline currents, driven by differences in temperature and salinity, transport oxygen to the darkest depths, sustaining life where sunlight never penetrates. These deep currents also ferry nutrients and organic matter, creating a delicate balance that supports creatures from the smallest shrimp to the largest squid. The dance of the currents is never-ending, shaped by wind, the rotation of the earth, and the shifting of the seasons. When currents shift or falter, entire ecosystems can be transformed. Coral reefs may bleach, fisheries may collapse, and migratory routes may vanish. In this hidden world, the pulse of the ocean is set not by the tides or the waves, but by the silent, steady flow of currents. They are the lifeblood of the sea, connecting distant realms and sustaining the delicate tapestry of marine life. Through their endless motion, the ocean's invisible highways remind us that in the vast blue world, everything is connected. Far below the reach of sunlight, where pressure crushes and temperatures plummet, life persists against all odds. This is the realm of the deep sea, a world so extreme that only the most remarkable creatures survive. Here, adaptation is not just an advantage, it is a necessity. In the perpetual darkness, many inhabitants have evolved extraordinary senses. Some, like the colossal squid, possess eyes as large as dinner plates, maximizing their ability to detect the faintest glimmer of bioluminescence. Others, such as certain species of deep-sea fish, have lost their vision entirely, relying instead on heightened senses of smell or specialized lateral lines to detect movement and vibrations in the water. To withstand crushing pressures hundreds of times greater than at the surface, deep-sea organisms have developed unique cellular chemistry. Their cell membranes contain flexible lipids, preventing them from becoming rigid and brittle. Proteins within these creatures are specially structured to maintain function when squeezed by immense forces, allowing vital processes to continue unimpeded. Food is scarce in the abyss, and survival often hinges on efficiency. Many deep-sea animals, like the gulper eel, possess enormous mouths and expandable stomachs, allowing them to consume prey much larger than themselves when the opportunity arises. Others, such as the vampire squid, feed on marine snow, a constant drizzle of organic particles descending from the upper ocean, filtering sustenance from the sparse offerings of the deep. Camouflage is an art perfected in darkness. Countless species have evolved transparent bodies, reflective scales, or deep red pigmentation, rendering them nearly invisible to both predators and prey. Some wield light as a weapon or a lure. Bioluminescent organs called photophores dot their bodies, flashing in intricate patterns to attract mates, startle enemies, or entice unsuspecting victims. Reproduction, too, demands innovation. Many deep-sea creatures release vast numbers of eggs or larvae, increasing the odds that a few will survive the perilous journey to adulthood. Some species, like the anglerfish, have evolved extreme reproductive strategies. Tiny males fuse their bodies to much larger females, ensuring they are always ready to fertilize eggs in a world where encounters are rare. These adaptations are the result of millions of years of relentless evolution, each trait a testament to the resilience and ingenuity of life. In the silent, crushing darkness, deep-sea creatures have become masters of survival, proving that even in the planet's most hostile environments, nature finds a way. Beneath the crushing darkness, survival often means forging unlikely alliances. In the deep ocean, symbiotic relationships are a lifeline, complex partnerships that allow creatures to thrive where isolation would mean certain death. One of the most remarkable examples is found at hydrothermal vents, where superheated water, rich in minerals, gushes from the seafloor. Here, giant tube worms flourish in a world without sunlight. Lacking mouths or digestive systems, these worms rely entirely on dense colonies of bacteria living within their tissues. The bacteria convert toxic chemicals from the vent water, like hydrogen sulfide, into energy through a process called chemosynthesis. In return, the tube worms provide shelter and a steady supply of nutrients. Together, they create vibrant oases in an otherwise barren landscape. Elsewhere, the flashlight fish glides silently through the blackness, its body dotted with glowing patches. These lights are not its own, they are the work of bioluminescent bacteria living in specialized pockets beneath the fish's eyes. The fish offers the bacteria protection and nourishment. The bacteria, in turn, help the fish communicate, attract prey, or evade predators with sudden flashes of light. In the open ocean, the Portuguese man-o-war drifts on the currents, its tentacles trailing like living nets. What appears to be a single creature is, in reality, a colony of specialized polyps, each with its own unique function, from stinging prey to digesting food or keeping the colony afloat. This division of labor is a form of symbiosis so complete that the individual polyps cannot survive alone. Even the smallest inhabitants of the deep play their part. Tiny, cleaner shrimp set up shop on the bodies of much larger fish, plucking away parasites and dead skin. The shrimp gain a steady meal, their hosts a much-needed spa treatment in the depths. These partnerships are not mere curiosities. They are the foundation of life in the deep sea. By working together, species unlock new possibilities, transforming the abyss from a place of scarcity into a thriving web of interdependence. In the silent darkness, the greatest strength is often found not in competition, but in cooperation. a testament to the enduring power of partnership beneath the waves. Far below the sunlit waves, the deep ocean has long been a realm of mystery and resilience. But even here, out of sight, new and unprecedented threats are gathering. The abyss, once thought untouchable, is now vulnerable to forces that originate far above its dark expanse. One of the most pressing dangers is deep-sea mining. Driven by the demand for rare metals used in modern technology, mining companies are eyeing the mineral-rich nodules and hydrothermal vents scattered across the ocean floor. These extraction operations risk destroying habitats that took millions of years to form. Sediment plumes, stirred up by mining machinery, can suffocate delicate filter feeders, disrupt food webs, and cloud the water for kilometers, making it difficult for animals to feed or communicate. Pollution, too, finds its way to the deepest trenches. Microplastics, tiny fragments of discarded waste, sink relentlessly, accumulating in the sediments and entering the bodies of deep-sea creatures. Heavy metals and toxic chemicals carried by ocean currents can become concentrated at depth, posing silent threats to the health and reproduction of species uniquely adapted to life in the dark. Climate change is reshaping the deep in subtle yet profound ways. As the planet warms, ocean currents shift, altering the delivery of nutrients from the surface. Oxygen levels in the deep are falling, a phenomenon known as deoxygenation, forcing some animals to abandon their ancient haunts in search of more hospitable waters. Acidification, caused by the ocean's absorption of excess carbon dioxide, is weakening the shells and skeletons of deep-sea dwellers, from tiny plankton to towering coral gardens. Even noise pollution, once confined to the surface, now echoes through the depths. The rumble of distant ships and the thrum of industrial activity can disrupt the navigation and communication of whales and other sound-dependent species, adding to the stress of an already challenging environment. These threats do not act alone. Their effects overlap and amplify one another, challenging the resilience of even the hardiest deep-sea survivors. The abyss, shaped by eons of slow evolution, faces rapid change on a scale it has never known. Yet despite these mounting challenges, the deep ocean endures, its mysteries intact, its life still astonishingly diverse. Understanding the threats facing this hidden world is the first step toward protecting it. Only by shining a light into the darkness can we hope to safeguard the deep, ensuring that its wonders persist for generations yet to come. For centuries, the deep ocean remained beyond our reach, a world glimpsed only in legends and the fleeting shadows cast by drifting nets. Today, that veil is lifting, thanks to extraordinary leaps in technology that are transforming our understanding of the abyss. Remotely operated vehicles, or ROVs, glide silently through the inky blackness, their robotic arms collecting samples and delicate organisms untouched by human hands. Equipped with high-definition cameras, these mechanical explorers capture breathtaking images of alien landscapes, towering hydrothermal vents, shimmering methane seeps, and forests of glass sponges. Their lights cut through the darkness, revealing colors and life forms that have never seen the sun. Autonomous underwater vehicles, or AUVs, roam the deep independently, mapping vast stretches of the seafloor with sonar and laser scanners. These machines can dive for days at a time, tracing underwater mountain ranges and discovering previously unknown trenches and canyons. Data they gather on temperature, chemistry, and currents help scientists piece together the intricate puzzle of deep-sea ecosystems. Sensitive sensors, smaller than a coin, now hitch rides on deep-sea creatures, tracking their movements and unlocking secrets of migration, feeding, and behavior. Environmental DNA, or eDNA, technology allows researchers to detect the presence of rare or elusive species simply by analyzing water samples for traces of genetic material. Even the sounds of the abyss are now within reach. Deep ocean hydrophones record the haunting calls of whales, the crackle of volcanic vents, and the subtle rumble of shifting tectonic plates. These audio records help scientists monitor the health of marine life and the pulse of the planet itself. As technology advances, so too does our responsibility. Each new discovery deepens our appreciation for the complexity and fragility of the abyss. With these remarkable tools, we are not just observers, we are stewards, entrusted with the knowledge to protect this last great wilderness beneath the waves.